All right, this morning we've got an opportunity to look at charging system testing. And what I would like to do is start with this vehicle behind me with the Chevy Silverado, and we'll go ahead and take the camera and hopefully not get you too dizzy. And we'll just look at the specs on it. So this is a 2007 model year, and it is a 4.8 liter V8. So it is a V8, but it's a 4.8. And if we look over here at the VIN for just a moment, you should be able to see, there's the VIN there. See if I can get close enough so you can see it. Yeah, and it says a C1, so C is that fifth digit's a C, which means it's a two-wheel drive. And then the one after it means that it's a half-ton. So this is a 07 4.8 liter half-ton two-wheel drive Silverado. So what we're going to be doing is we're going to be testing the charging system. There's the alternator there, and it's driven by a serpentine belt. And you remember that we can take a tool and look to see if we have if the serpentine belt is worn, so we can get down in there and look at the grooves, and we can take our little tool to measure that. And I'll show you that in just a moment here. So I got my little tool here, and I'm giving some light down there, and I can put this tool in there, and then what I'm going to do is try and feel across there. And I don't know how well you're going to be able to see it, but I'll do my best here to look across that thing and see if it's submerged or if it's proud. It feels like it's a little proud, which means that's good. That means it's not so worn. But I also see some cracks down here on the belt, which some cracks are considered to be okay. The belt is pretty dry, and this is maybe a better spot for me to test it because I can get the camera on there. And it's sitting in there. Sorry, I'm having trouble doing this with. No, it's down below the belt. So this belt is worn out, and we should replace that, because when you look across this thing, if it's even with the tops of the ridges, then it's worn out. This thing should be sitting up a little bit. So we think we're going to have to replace that. So I'm going to put the camera up here. Again, I apologize, it's so jerky, etc. And what I'm going to do is, there's my battery over there, and I'm going to try and carefully wheel my screen and recording stuff over here so you can see the battery there. And when you look at the battery, it's a little hard to see from where you are, but there's the positive and negative terminal. Come over here, get a better look at it. Here's the positive terminal there. There's the negative terminal there. It's a maintenance free, so we can't check the water. I don't see a date code handy to know how old it is. But what we are going to do, and actually maybe I could put this up here and look across it like that. I'm going to take the voltmeter, and the first thing we're going to do is what we call charging system voltage. So we're going to look at the charging system voltage on this guy, and I know you're just fascinated by my professional recording skills. So I'm going red to positive, black to negative across the battery. So there's my leads. I just use the alligator clips to get onto the negative there, the positive there, and to the negative there. Now what I'm going to do is I'm going to go ahead and start the car, and you will see the charging system voltage. We expect to see 13.5 to 14.5 volts. And right now we're resting at, look at this, we got rat poop right here. So obviously there's been rats living under this thing. But we're showing this thing at 12.53 volts. So let me go start it and kind of wedge it in here so you can see the screen. I will start it, and we will see what we get. So here we go. I'm starting the car up right now. So you can see on the screen that the charging system voltage is 14.77, 14.78 volts. So it appears that this thing is charging. And you probably can't hear it very well, but we are getting a little whining out of this alternator, either because of the sounds like the buzzing out of the alternator, which is fairly normal. Sometimes this idler pulley makes a little noise. The belt's a little dry. It does need a belt. It is interesting to note that this 07 uses 2 electric fans and not a belt-driven fan, which is kind of interesting. And yes, it needs a pressure wash and needs to be cleaned up, and we'll be doing some of that. So our charging system voltage is sitting around 14.8 volts. So it looks like it's charging. But now what we're going to do is we're going to go ahead and do a alternator output test. And we can do this a couple of different ways. So let me go ahead and hook up our machine. I'm going to go ahead and hook it up, red to positive, which is a little challenging. Oh, there we go, I got it in there. And black to negative, if I can get it down in there. I think I can. There we go, red to positive, black to negative. Then over here on the machine, if I can pull this off and not make you too dizzy. Over here on the machine, I've got the amps connector off, and I can zero the ammeter. I had it zeroed, but I'm just kind of showing you I can adjust it down to 0. And then the most accurate way to do an alternator output test, as I pull the machine over, is come over here to the car and get this inductive lead around the battery or the alternator output lead. I can put it around the battery cable over there at the battery. But if I put it around this guy here, I'll get the most accurate output. Now, what we're going to do is I'm going to go ahead and set the voltmeter and its inductive amp aside. And when I start the vehicle, we should see that charging system voltage on the screen. This machine is not as accurate as that digital volt-ohm meter, so just be prepared for it to be not exactly the same. Let me turn it like this and put this here so we can see it like this. And so what's going to happen is I'm going to put a pedal depressor to the floor and onto the gas pedal, and I'm going to get it up to 2,000 RPM. Then I'm going to come out here. This is going to be reading about 14.4 volts. I'm going to turn this guy up, which is a load. This loads the alternator. This is going to suck power and expend it on what's called a carbon pile. A lot of modern cars won't let this test work. I believe this 07 will. It's old enough. We're going to read the max amperage and not let the voltage drop below 12.6 volts at 2,000 RPM. So once again, I put the pedal depressor on the throttle, hold it up at about 2,000 RPM. I'm going to come out here to load this, get the max amperage at 12.6 volts. We are stressing the alternator. So let me get that set up. So here I am back with the pedal depressor that you can see. I'm going to go ahead and put onto the throttle. When the car starts and it's at 2,000 RPM, it'll be loud, so I'll just be pointing to here and here when I crank this up. So you're going to see in here, I'm going to have the pedal depressor on, and the tach is up around 2,000 RPM there. You should be able to see it. There's my pedal depressor. When I release it, I just push there. So I'm going to come back out here. We can see that this thing's charging at 14.5 volts, and it's at about 40 amps already, and the reason is because we got the headlights back on again. I'm going to go ahead and crank this up and get the amperage as high as I can, not letting it go below 12 volts, right about there, right there, about 105 amps, 107 amps at 12 volts, maybe 109. I'm gonna let it off there. Okay, so you can see that that thing was running right about 109 amps at 14.4 volts on this load tester. Modern cars aren't going to let you load test it with this. Modern cars are going to shut down the alternator. They're going to shut down the alternator, and because the computer sees all this current going out of the alternator, it says, "No, I'm not doing it." Shuts the voltage regulator down, doesn't let the alternator charge. So we have to use, in that case, we have to use that voltmeter with the inductive lead that we have here. We've got to use something like this and follow ProDemand telling us, okay, you're going to have to hook this guy up. You turn on the headlights, run it at 2000, turn on the AC, and decide where it's at. Okay, so that's charging system voltage. That's doing a load test. And now what we're going to do is, we've also checked the belt and decide we need to replace it. Now what we're going to do is show you how to check a alternator rotor for shorts and grounds, shorts to ground, and for opens, and see what the resistance is, as well as the stator. Let's do that. Okay, so what we're going to do now is we're going to show you how to test some alternator components. I'm going to take my leads, my banana connector. I'm going to take off that alligator clip. I'm going to put on a probe like this. First thing I'm going to do is look at this rotor for shorts to ground and opens, and resistance. I'm going to put the meter to ohms, so you can see the Greek omega symbol and auto zeros. And I can put this down. It's going to read OL because that means out of limits. Let me drop the camera a little bit. If I touch these together, you're going to see that the meter goes to about 0, or I'm getting close to, sorry, I can hold this tight. So about, okay, so that's a little bit janky. Should be closer to 0. Let's see if we can get it closer to 0. So there we go. And for whatever reason, this meter is not zeroing. So let me get another meter. Okay, I don't know if the battery was low or whatever, but now it's zeroing. So it's going down really close to a 0, which is 3/10 or something. What I'm going to do is I'm going to check this first for continuity. So I'm going to go on this rotor. I'm going to touch to these two sides of the slip ring. And if I can scratch them and get a good contact, you can see, trying to get this thing to stabilize. I'm going to see if I can get another meter that'll stay. All right, so this one's obviously zeroing much better. You can see it's reading OL. When I touch it together, it goes to like 1/10 of an ohm. So I'm assuming on this other meter that the battery may be going bad. So I'm going to go ahead and swap this lead out here, and I'm going to touch the rotor across the slip rings like this, slip ring to slip ring, and I am reading about 3.1 ohms, so about 3 ohms of resistance in that coil, and you can tell that means it has continuity. It's not broken. It's not reading OL, and about 3 ohms is normal for the amount of wire that's in there. Now I'm going to check this rotor for a short to ground, so I'm checking from either slip ring to the case, and I should go to OL, or from either slip ring to the shaft, and I get OL. So there's no ground. So this thing is it's got continuity through the coil, about 3 ohms of resistance. There's no ground here. So we can say that this rotor is good because there's continuity in there. It's about 3 ohms of resistance. There's no shorts to ground. We're going to look at the stator now. So same thing with the stator. We're going to go across the leads. We're going to go to these two, and we get about 3/10 of an ohm. We go to these, get about 3/10 of an ohm. We go to these, we get about 3/10 of an ohm. So 2/10, 3/10. So there's 3/10 of ohm in these wires, and it's a lot less than this coil here because there's just a lot less wire. Finally, we're going to touch from one of these leads to the case, and we should get OL, so it's not shorted to ground. So we've checked both the stator and the rotor for shorts to ground and, sorry, I interrupted myself, and continuity. Finally, we're going to go ahead and test these diodes and show you how to test the diodes. So what we do is we put this on the ohm setting here. See if I can get it so the glare is not so bad. And what we're going to do is we're going to push this, and we see a tone symbol. Push it one more time, and we see a diode symbol up there in the corner. So now we can check this for diode resistance. What it does a voltage drop on this. So I'm going to touch this from this diode to the plate. Let me do that again. From this diode here to the plate down here, and then I reverse the leads. And what I should get about a half a volt in one direction, and when I reverse the leads and go the opposite way, I should get OL. Now, part of the problem is I got to make sure I'm insulated here. So I go on this guy here, right there, and I get about a half a volt, and then I swap my leads here and go there, and I get OL. That one's reading correctly. So this one I get OL, this one I get, let me get the other one down there. I get this OL on this one. Sorry. Now if I swap the leads, should get about a half a volt, yep. Should get about a half a volt, yep. And on these, if I touch here, OL, 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 and then if I reverse the leads, I get about a half a volt, and half a volt. So all these diodes are good. And again, I was just checking from that diode there to the base there, or this diode here to its base here, and then swapping the leads. All these diodes are good. There's nothing wrong with these at all. So that shows you how to not only check the rotor and the stator for shorts, etc., but also the diodes. One final thing, again, we can sand these slip rings to get them good, and we can replace the brushes if we're rebuilding it, replace the two end bearings, and that's what's involved in rebuilding an alternator. Okay, so that's it. There you go.